Good afternoon, Ankit sir. Can we start with the session?
Hello, good afternoon.
Can we start with the session, sir?
Yes, we can.
Good afternoon, all the participants. Here we are today with the second session on day 3 of online PPT. So, the topic for the second session is sampling design, and for taking this session, we have with us Dr. Ankit Chaudhary, who is Associate Professor at Jawaharlal Nehru University, New Delhi. Dr. Chaudhary has 7 years of extensive experience and has been a part of different research projects. He has published more than 85 research papers in his 17 years of teaching career, and his area of research interest are data science and cybersecurity. So I would request Dr. Chaudhary to proceed with the session. We are honored to have you here in the session, sir, and I expect all the participants will be having a brief interactive session with you. Over to you, sir.
Thank you. So I hope my PPT is viewable to you.
Yes, sir. Screen is visible, sir. If you are present.
Okay. So we are planning to talk the sampling design today and sampling methods. So sampling is a very useful and very practical things these days, where data is available in large quantity, actually very large quantity, and we need to analyze, we need to get some pre-result or some expected thing or some guess about what is going to happen. So it is very useful these days. Although it is very existing theory from a very long time, but according to the time, according to the scenario, many things has changed. So depend on your area of application where you have to do the sampling, you have to decide few things. In sampling design, if you are looking for some market related area, suppose you want to do some market research, or you are interested in some, for example, exit poll, that you want to take the opinion of the people before the poll or after the poll or about some policy. So it's about human related, or you want to do some agriculture related or forest related in your state. So there are different kind of applications where the sampling can be done, and in each type of area, each type of application, the sampling may be different. So whenever we need to do sampling, we have to gather some information about our application so that we can apply the application related constraints. Then we have to check what is our population size. If, let's talk about exit poll, India has around 1.4 billion people, where zero point 0.8 billion, that means 800 million, people are the voter in this country, where 0.55 billion actually do vote, and we have to see how much among them are eligible, we are eligible, or we can take the opinion of those people. I cannot go to around 500,000,000 people and ask their opinion. This is a too big data for anybody or even a team of 1,000 people to go and talk and take their opinion. This is a big risk. So we have to check what is our population. In the population, according to the complexity of the our application or our analysis which we are planning, we have to check how much sample we have to choose. So if somebody says any news channel, you probably would be seeing some news channel which says that my sample size is 1 lakh or 2 lakh of the people about the poll, and our results are very, very uh, trustable because the sample size is biggest in the history, 2 lakh. If you take the voter population in general election in this country, around 500,000,000 people, the 2 lakh sample size is actually very close to zero. So that doesn't make any difference if 500,000,000 people are voting. So we have to check how much sample size we have going to take or we are capable to take. Sometimes it is not possible that we can take a very big sample. Then in which unit we have to take? If we are going to take about the people, we have to check how many number of people, because there we cannot cut people into pieces. We can cut land, we can cut trees into the pieces like leaves, like kind of area they cover, but the opinion we have to take as the whole. Also, we have to see how much information or how much opinion we are seeking. Are we just asking yes or no from the, let's say in market research, we are asking some yes or no, but I'm going to 100 people, I'm asking, do you like some favorite brand, like the Domino's pizza, yes or no? If this is a very simple question, we can make very easy analysis. But if we are going to take the opinion, let's say I'm asking somebody's free flow opinion of 2 minutes from everybody, the person can say anything. And in that 2 minutes of 100 people, I have 200-minute data, 2 minutes from each. I have to see what is possible and what they are saying. I have to extract that information. So how much data in each sample is available, that also we need to ensure. So when we do the sampling design, we decide all these factors for a smooth and very reliable operation. In some cases, the data is already available. You just need to go and collect and just need to make these parametrical decisions, how much data you want, which type of data you want, in which format you will measure. In some cases, you have to create data, for example, opinion. You have to go and talk to people and collect the opinion, collect the questionnaire you are giving to the people in the market or in the public domain and collect those questionnaire. So either way, you have to do these decisions in sampling design. So the population is generally known in sample, that is the whole. Before the data science, I hope you know what is data science. This is one of the emerging area in the technical field. When, let's say we have whole population is 1 million. So it was not possible for a statistician or for computer people to decide something on that. And we were not able to process so much. So we were taking a very small set, we call sample. How we choose that sample, we'll discuss soon. And what parameter also we need to decide, that I just spoke. So that was to simplify our process or reduce our workload. And sampling just show one section of the data which we as the sampling designer has chosen, either based on randomness, either based on our uh, parameters, either based on our criteria, or somebody has told us how to do this. Either way. In all cases, the sampling will give you the idea of a subset which is coming from this population. If you need to take the whole data, if you take the whole population, you would be having a better opinion or better knowledge of the system. For that, we just process the data science or the data analytics so that we cover everything. We can have an example. If you go into a city, let's say Bhilai or Raipur, and you talk to 100 people and take their opinion, and you say people like something in the city. And when you come to me, I will say I don't like. And I think the 100 people you talk, they were just part of one group or they were all friends. They said the same thing. This is not true about the city. So whenever we make a decision on a small population, on a small sample, due to some constraint, because we can't process the whole population or we can't process the data, that has some limitation. So taking the whole population is always a good way, a good result oriented. Although in few cases it is not possible to go to all population and get the data. For example, if 0.55 billion people have voted in general election in 2019, I cannot go to around 500 million people and collect their opinion, what they say about the poll. It's not possible. So we have to do sampling in such case. If you have the recorded data, if you have some data in Excel sheet or data in some other format, and that may be 1 million or maybe 1 billion, in that case, we can process the whole population and we will need some different kind of machines and some technical expert to do that. So we have to choose a sample in case of sampling. So sampling in mathematics or in experimental way, it is considered a valid method. There have been different tests based on that, and this is considered scientifically proved method, a good way to analyze a larger population based on sampling. We may have several kind of problems. One is like in population, we can't, in normal human population, we can't go to each one. We may have some company related issues that we don't have so much budget, we don't have so much time, we can't do such big analysis at some time. So we have to go for short, and we have to say that our research or our work, whatever we are doing, is scientifically correct. So we go for sampling. Also, time is important. If you know about SO survey, which is based on some scientific method, all the public policies in the government are made on that data. That is collected and in a way that the people will go to every home, will collect the data, and will store the data in a very predefined format. Which questions to ask, they already have decided. In which way they will write the answer and how they will get fed into the electronic system, the computer system, that is already defined. Once we have this data available, let's say in the state, we have around, let's say, 2.5 crore population or 3 crore population, and we have gone to the people of NSSO, or let's say the people who are working on behalf of the government, has reached to around half of the population. It shows something like they have covered much area, and that would be kind of good information about the people, about the families living there and what they would be doing. And we have to see that a large area of the state or large area of the population, human population, has been covered in that case. Of course, this kind of survey, like the census, like NSSO, or doing with the data, whole data, what we call data science these days, that will take a big time. Of course, a big budget. And if you are a PhD researcher, or you want to do some paper publishing, or you want to take some opinion like the news channel, it is not quite possible every time to do such type of thing. And we just need to extract some information so we can show that this is directly coming from a crowd, and this is the mood of the crowd. This is what people are thinking. For that, a sampling is needed. So whenever we are going for the survey, you must have the question that how representative is the sample of whole population, and how similar are the characteristics of a small group of cases are chosen. This is where we call randomness or probability based regions. If we are having some big population, and we have to make some really good uh, sampling, just give me a minute. Okay, there's a when we are in the office, there is somebody there. So I hope I'm audible.
Yes, sir. You are.
Okay, good. So we were talking about the population and how the research happens. So when we look for our population size these days, this is much more than the population of this country or much more the population of the world. Uh, Even if we go for the market research or sorry, in the market for anything, or we take the, let's say, opinion of the restaurants in the city, there are so many online or so many uh, social media based opinion that we have to see, and once we have to take the uh, collective results in a way so we can analyze what should be the rating of some restaurant, and we can recommend on some uh, food ordering app that is going to be quite big these days. So it's a kind of a very important uh, decision that which method we choose, and in that method it is kind of uh, we have to see that all type of population, when I say all type, that mean there would be some section inside the population which need to be represented. So for example, if we talk the food opinion in the city, let's say in Raipur there are many restaurants, and in your state, and in the city Raipur, if we take opinion, we have to take opinion of the people, of the young people which are from 18 to 30. We have to take opinion of the people who have very different tastes from 60 to 80, and of course the kids who are in the age less than 10. So they would be preferring different type of restaurants, different type of foods, and their opinion would be very different. So in a population of human or the population of restaurant going people, we have to see if there are different sections. If there are, we have to make sure that we are collecting the opinion of all sections, and probably opinion of all sections in equal way, so that the weightage can be given equally, or you can take separate uh, population separately of these sections. Kids have these opinion, young people have these opinion, and elderly people have these opinion. So there are some sampling size, sampling frame, which we have to decide, and depend on the population. Actually, it has no relation with the population size, but again, it's your choice. If you have kind of 1 billion population, you can say 1000 is my sampling, although it's why quite small size. If you take 1 lakh 100,000, it is still very less compared to 1 billion. So you take 1 by 1000, I mean 1000 section or 10,000 section, it depends on your choice. Either way, the sampling will say that's correct. But to take the mood of the population, the mood of the whole data, you must have a big enough sample. So this is my population. This is, I'm taking sampling frame, which is smaller than the whole population. And this is my sample, which I'm going to work. In this figure, you can easily see that this is a very small compared to this one. This may or may not represent this whole mood. So I can take it a little bigger. So population have similar opinions may have different sections, and there are different type of constants also. So let's see. So if all are homogeneous, the life is very easy. You have to, for example, you work for a TV channel, or you work for this media agency, some agency who collect the this TV ratings of the TV channels, called TRP of some soaps, TV soaps, or uh, somehow which channel people like most, kind of the such uh, marketing things. So every house has a TV. Now they also have this set-top box, and they would be seeing some channels. So if, let's say, every set-top box you buy from either company, they have some similar kind of protocol. In that case, they would be having same data which they are recording. Let's say I watch one channel and you watch another channel, but frequently we change the channel also. So in a day I see 10 channels and you see 5 channels. Either way, uh, that kind of data is going to be homogeneous, because we are sometimes watch news, sometimes we watch movies, sometimes we watch cartoon in a house. So and there is one TV, one set-top box. It is going to be quite similar. While in some cases we may have very different kind of data, and we have to go with that. For example, if we have to go for NSSO data, which is the public policy making data for the country and the state also, there are some constraints from the government that you have to go to some reason. Let's say for the tribal reason, you have to go to the people who are below the poverty line. You have to go to the people who have, let's say, X kind of constraint or the Y kinds of constraint. So there are different sections already defined. The people who are having no or low education, or the people who are having very few resources. So we have to divide the population into the different layers or different boxes, different categories. So when we have a whole population divided into 10 different layers or 10 different boxes, we have to choose the sample equally from each boxes, or in equal ratio from each. So that is stratified or strata. And this is very important in every section. If we go just by randomness, or just by I will give equal opportunity for each data point in the whole population, that will create a very different kind of mood or different kind of result in the data. For example, if you take the voting opinion exit poll kind of thing, and you talk only in Bhilai, Raipur, Bilaspur, and you don't go to the tribal areas or the rural areas, that would be a very different opinion. If you go for NSSO data and you go only to, let's say, in the central Raipur, or let's say near Raipur, then you would be having a very different data than you are going to some rural or other kind of people where they are living. So we have to take the sample from each section, and the randomness, or the we call it equal probability for each data point, that is not very practical way to get the good result. Also, in some government or some committee based research, it is quite necessary that you have to represent every section of your population, so that the data which you are having can be represented clearly. Then we have the proportional stratified, which is contains strata, that means the sections of known proportions. That is probably a version of this where we can take the data into sections of equal ratio. Then we have different way. We can group by type or group by location. If let's say I work in a university in New Delhi, and in my university we have mapping of every city, every district of the country, that where people are, it's district wise, where people are more educated and where people are less educated. It's not the city wise. So for example, Raipur is a district. It includes the city and the rural area both. And accordingly, we give some preference the people who are coming from the low educated districts, and we give no preference to the people who are coming from high educated districts. So that's kind of location based grouping we do, and we do that kind of stuff. In the market research, the location wide sampling is quite important because location has different kind of characteristics, including weather, including food, including income. That depends. In coastal area, the way of living is very different than the people who are landlocked, and the opinion, the living style would be very different. So we cannot take two cities, one from the coastal area, one from the landlocked, and we can merge that both opinions or merge both results. That would not be a good way. So let's see the sampling methods. So we can say the green one, which is on the left side, they just called random sampling based, or some randomness is required there. We'll talk what is randomness in computer or what is randomness in the real world. And on the right side, in blue, these are called non-random method or convenience-based method. So let's talk about first randomness. We say normally if you have been a student of science, you know there is some called random variable in math. Let X be a random variable, which is a random in all sense. There is no such thing called random in the real world. When you say there are 1 to 100 number and I will choose some one number randomly, so you will choose. You are the person who is going to choose. So you have some bias. It depends, you will choose before 50 or after 50. It's your choice. You are making a choice. Similarly, in computer, because computer is a deterministic machine, it is not like it will make some random move. It will make some move which is predefined, which you are asking. In such case, something is already programmed and it will do exactly the same thing. So if this is the human thing, the natural thing, if still somebody is making a choice. If this is computer thing, the system is doing something. It is already predetermined. Although there are ways to make this pseudo random, which is half random or some randomness to show that some randomness is there. But in all cases, in overall, the randomness will include some kind of biasing. So when we say simple random sampling, the first one, I hope you can see with the cursor, this shows that there are, let's say, 1,000 data points, and I will choose 10 points out of 1,000 randomly. Now, when you say you will choose 10 points from 1,000, that means you are going to make the choice. Let's say you have 100 people in the room, and you will choose 10 points, 10 people from those 100 people. So how you will choose? You will see the person and you will say come out, or you know the person, you will say come out. Or let's say you know the person, you will say okay, you sit and come the next. So you will make some choice. Also, let's say you don't know anybody and you are somewhere and you will choose 10 people out of 100, and let's say you have no biasing, you have closed your eyes and you don't know anybody either way. Now the people, 100 people in the room, or the 1000 data points in the some statistical or some computer data, are we sure they are collected, they are defined in normal way, or they are defined in the starter way, like low income, high income, low education, high education group, or they are just put together? So if you are choosing randomly 10 people, it is possible you are choosing 8 highly educated people and 2 low educated people, while in the population of 100, the 60 people were from low educated. So the randomness can create a problem also sometimes. So it is quite difficult, even if there is no biasing from any side, that the randomness will not give you the mood of the data. Let's take the exit poll scenario. The journalists, they go to big cities, Bhilai, Raipur, Bilaspur, Delhi, Bombay, Hyderabad. They take opinion of the people who are in the market. They never come to my house. So I did not give any opinion. I'm also citizen of this country. I also vote. So how they can say what is going to happen in the exit poll or in the poll? Because nobody asked me, how they can claim this is the mood of the public. Me means anyone. So when I was not part of the consideration, I was not part of the population, but the constant the journalist is having, that they are not interested traveling to all the people, one, traveling to the distances, two, traveling to the remote areas, three, also the channel has to spend money. And if you are a researcher or you are a PhD student or you are a faculty member, either way, you have to spend money and the time to go to the places to collect the data. Even if you work in the agriculture field or you work in the political science field or you work in the social science to collect the data, or even if you're a computer scientist or MBA graduate. So you have to collect data, you have to go there. So that had some problem. The money problem, the constant problem, there are many constraints, and of course, when you will collect, what kind of data you will collect, that is your design, your questionnaire design. So we do sometime the stratified sampling, which we just discussed, that we will put the data into some groups. One, let's say we are talking about NSSO. I hope everyone knows what is NSSO. We divide the whole data, let's say 1000 data points, into groups. The 300 are high educated, the 600 are low educated, and 100 are no education. So now there are three groups. So when I'm going to take the data, I will take from each group equally, or 30 from one, 60 from two, and 10 from the third group. So they will be having the equal representation in the data. So when I'm going to check what data is saying, what the whole population was saying in the sample, I would be having the same mood of the data, the same feeling of the data. I would not be just blindly taking the randomness. Something is called systematic sampling. This is kind of interval based in few applications. For example, in agriculture data, if you work with the agriculture department or the irrigation department of any government in the country or outside country, you have to see what people are doing with the land, what is the land sample, the soil sample, not the data sample. What is the land sample? How much they are earning and what kind of problems they are having. So when you go and check every fifth field, farming field, or every 10th farming field in the on the ground, or you do aerial survey and you take the what is the people are growing in one region. Let's say in Jabalpur, what people are growing in Nagpur, what people are growing in their field. So we take the opinion of every 10th field or every 100th field, farming field. So that kind of interval based, fixed interval based sampling is called systematic sampling. In case of human, that would not be a good idea, but people also do that in case of human also. If we have 1,000 students who have taken the let's say some exam, and I need to say about the background of the students, that how they performed, I will take every fifth student and I will say, okay, they have done good. It may happen that most of the fifth person, the fifth, 10th, 15th, have done good, so I will say exam is good. In case of human, or in case of the things which change differently, we have to be very careful. In case of non-living thing, in case of things which rarely change, we have to see how the interval based can work. We can take a data pre-COVID and post-COVID. The pre-COVID, the scenarios were linearly growing, linearly going down, hardly any change in NSSO data. It was almost same. The same policies are running since 50 years. After COVID, if you see the data of the people, many things have been changed drastically, maybe up, maybe down, and there are different type of effects people have seen. There have been, if you see the data, it is very skewed after that. So we cannot apply the randomness theory, or the systematic theory on such kind of data. Okay, let's come to the blue side. We have a sampling is called convenience sampling. As the name is there, it's based on your convenience. As I said, that journalists, they generally go to the big cities, mostly in Delhi. If you see the national channels, they just go to Delhi or NCR. They will talk to 100 people and they will say, this is the mood of the country. So this is the convenience, that you go wherever you want, you choose to people wherever, whichever you want to talk, or whoever is free to talk, whoever is standing on the road for you. You will not talk to the people who are really interested. So it is based on your convenience. And when you are making the decision based on your convenience, not based on the real feeling, not based on the real opinion, of course, you know what you would be representing. So this is not very trusted sampling. Although people do this for solving the constraints. You don't have money from the university or from the budget or from the company, so you can't go anywhere. You don't have time, you have to do sampling within a day, so you will talk to 10 people who are near to you. Sometimes many people talk in the lab and they prepare the data. So it depends where you want to go and what kind of resources you have. Similarly, we have judgmental, or based on some purpose, which is similar to the convenience. Convenience will include that. And we also have one is the quota sampling. Quota sampling is similar to stratified, but here we pre-fill the quota, that it would be 50% from this, 30% from this, and 20% from. And in some, if you do some government related sampling, the data collection and the sampling, you will find this kind of quota would be there, and you have to represent the information accordingly. So the green one or the probability based sampling, they give the most reliable representation of the whole population. And the blue one or the non-probability based techniques, they rely on the judgment of the researcher. So it depends how experienced the researcher is, and the researcher is having no bias. So accordingly, we can rely the judgment. So this is the theory, what most of it we already discussed, that in the probability sampling, it's a sampling in which we take a piece from the larger population, and they are chosen based on some method, maybe based on randomness, maybe based on probability. The point is here, every point in the population has equal probability to go inside the sample. Now, in theory, because sampling is from statistics, in theory, there must be some randomness and the sample must be selected using a random selection. As I said, the random is in question because the human will make or the computer will make this randomness. That if you know how the computer works, you know that computer is a machine. It's very much mechanical machine and need to be told how to behave. It will behave in the same way. So every point must have the equal chance of getting selected. This is the main point in probability sampling. So if you choose 10 people out of 1,000 and everybody has equal chance, it is possible that you may choose 10 people or 8 out of 10 people who belongs to one group. If your data is homogeneous, the probability sampling is a very good method. If your data is not homogeneous, you have different sections to represent in the data. In that case, you have to see other kind of sampling and probably the stratified sampling. If you have to see the cell of the car and the cell of the bike in last year, then the probability sampling would not be good because we have two different sections. If you say I just need to see the cell of automobile in last year, then the probability sampling has the right choice, is the right choice. This is what we just discussed. So in stratified, it involves a big population and that is divided into smaller groups. And in this one, we usually, this is called usually don't overlap because there would be people who would be in two groups, but we try to make sure they are not overlapping. In the quota sampling, there is no overlap at all. So this is the main difference. So this is my sampling stratified where I have taken three different groups. One is this group, one is this group, and one is this group from different three groups. I have taken them together. This is my sample. So it depends on your whether you work for the government or you are collecting data for the government or you are collecting data for a political science research project or maybe for a market research. You have to check whether you are interested in some factor. If you are selling something for female related products, you have to see what they are having in the. You have to go and check for the female opinions of what kind of opinion they are having. If you are selling something for kids, then only you have to check for them. It depends very much that you have to focus only on that group. If your product is very generic, let's say you are selling Domino's pizza or a new kind of pizza, you have to check who is liking it and what kind of percentage, what kind of people, what percentage of people we should target in our advertisements. For example, Maggie, take the example of Maggie. Before the controversy, it was for the kids. The kids were dancing, there were movie actresses who were giving advertisements, and all were happy with that. After the controversies, the Nestle changed the advertisement and they brought mothers or the females to show that this is trustable. So it depends that what kind of opinion people are having and who is the opinion maker in that case. The market research need to find out so that the companies can target them in their next action. So we may have different groups. This is one example that you have 800 full-time and 200 part-time employees in a company. And if you need to draw 100 employees, then you have a simple random sample of 80 from here and a simple random sample of 20 from here. So you are taking equal percentage. That is the best way. If you just choose 100 people, it is possible they are coming all from here or 90 are coming from here. So that would not be a good representation of the whole data or the population we have. So this is kind of equal representation should be given in the data to have the true feeling or true mood we have the sampling. Cluster sampling. In cluster sampling, we have the points, data points, or the data values which are clustered together. And we choose that cluster. Let's say we got 50 clusters. We choose 3 clusters or 5 clusters from that 50, and every cluster has 10 points. So I choose 3. So it's kind of grouping. And the clustering also has multi-indexing and multi-layering clustering in further as a classification. If you see the difference in stratified and clustering, so population is divided into few subgroups in originally based on, I mean, they are divided before you reach to the population. It's the way they were collected. Each subgroup has many elements and subgroups are selected accordingly to some criteria. So it is homogeneous within the subgroup. Let's say we have 800 full-time employees. In last example, they are all same, and 200 part-time, they are all same. In cluster, this is not the case. In cluster, we take one cluster, let's say 2 full-time, 1 part-time. We took one group or one cluster we made for 3 employees, 2 full-time, 1 part-time. Then I made another cluster, 2 full-time, 1 part-time. So if you choose any cluster, you choose 5 clusters. So you would be having 2 full-time, 1 part-time, and 5 of this. So total 10 full-time and 5 part-time. So it depends how you make the cluster. So this is not the case with stratified. It is different from the subgroup. We have 800 full-time and 200 part-time. So there are 2 different groups. There is a heterogeneity. There are differences. All clusters are almost same. If you have the enough data, the all clusters would be same. This is a difference. Here, we make the choice of elements within each subgroup. I will take kind of equal share of each subgroup. Here, we make random choices to choose which one I need to take from the clusters, from the subgroup. Systematic sampling, as I said, is the interval sampling. I will take the 3rd employee, then the 6th employee, then the 9th employee, then the 12th employee, then the 15th employee. This is equal. But is it really going to be the real version of the data, the real mode of the data? That we need to see. I think my time is 1 hour, so I would be winding up soon. Okay. Convenience, this is no probability sampling, and this is basically mostly based on your choice, the ease of access, the readiness of the data, how much time it will take, time slot, how much time you have, and any other practical scenario. The money is there actually. It's not given, but once you are part of the job in any government or private or any media company who generally take the data sample, the money is a big factor there. And of course, your choice how far you want to travel. So it involves selecting haphazardly those cases which are easiest for sampling and interview such people who are at the shopping center for a television program. This is well-known thing. You know how things happen these days. People go to a mall and take that an interview because people are there. If you're on the road, or if you are going, let's say, to Raipur to Sambalpur Road, there is hardly anybody on the highway. So you cannot take interview of somebody. You have to ask for a car to stop, give some interview. They will not stop. So people generally go, the data collectors generally go to the place where there are a lot of people and there are 100 out of 100, somebody will speak. And when you are in a comfortable zone, people generally speak. In judgmental, the members are chosen only on the basis of researchers' knowledge and judgment. So it's kind of already set. So it enables you to select the cases that will enable you to answer questions and who would be meeting your criteria. So if you see this is my uh, population and I'm the researcher, I will choose whom I'm willing to talk or I'm going to talk. In convenience also we do the same. I choose to whom I will talk. It's not random. And actually, if you as a human, if you see, you choose to whom you are going to talk. It's a bias there. Okay. There are many ways I would suggest people. If you have any question, please let me know. And one thing, as I said before, if you want the sample, it's quite uh, short, quite small, and you can take some opinion. Although if it is some straightforward data, you can use data science and use the whole population so that you would be having a great mood. My PPT is visible? No. Okay. So if it is possible, you can take the whole data and it would be a good thing to see how things have been in the data. The sampling can give you some idea if it is very much really randomized and very much correctly collected. Although what the real data is saying, that may be a very different what sampling is saying.
So you can put it in a slideshow mode. You can see the first slide right here.
Yes, this is what I'm showing right now. So if somebody has any question, please let me know. So there is a question that for the same study, do time and technology have any effect on the sampling size? The answer is yes. Uh, if we have I mean, these days we have the technologies where we can easily go for the bigger sample size. In, I mean, before last few decades, we were not so easy with the computing powers, and the computers were not so easily accessible like the iPads and other things. So the collecting of the data was a problem. And once we have the data, it was mostly human who were writing the data. So they were in the paper format, not in the electronic format. So human is collecting the data in human decided format. So that was not, I mean, converting this into electronic was a big problem. Although also so many errors. Nowadays, when somebody comes to you for the data collection, they have the questionnaire in the e format in some tablet or mobile, and they just put that data, the e format directly. In your state only, most of the health record data is in e format with the health department in Raipur. So most uh, these days, mostly the data, the sample size has grown. Before, if I'm working with pen and paper, out of 1,000, I will take only 10 samples. Nowadays, because I have 10 lakh data size, I will take around 1 lakh or maybe 50,000 because I have to work with computer. Also, the accuracy of the results, or results means what the data is actually saying, the mode of the data, that have been uh, improved, because if something is not working, I can try different technology, I can try different techniques, and that can show how good we are. On the with the pen and paper, mostly the human analysis, we were not able to do that much variance. Also, there is a department in central government called Department of uh, Statistics and Data and Statistics now. I think it's a ministry now. They are mostly working with this, and they are collecting a lot of data about the country, where the sample size is, of course, very big because the population is very big. Okay. Any other question? If anyone has a question, please let me know. Okay. There are many tools available these days, many GUI based tools. Also, there are many programming based tools. Like in R, you can do the sampling easily. In S, which is a language for statistics, you can do the sampling easily. You can do that in the Minitab also, which is a GUI tool. Although I would suggest you, if you are doing some research for yourself as a PhD student or faculty or for the government, take the sample size as big as possible. Or what we do, we take the whole population actually, which is we call data. This is my data. I will give you one example before I leave. You know, we have mobile phones in this country. So population is around, let's say 1.4, and we have around 3 billion mobile phones in this country. And okay, it doesn't matter how many we have, we talk whole day on the phone, over the phone. Either you are, I'm talking only mobile phone, not the basic, not the line phone. We either if we have over the in the office, we are in the office, we are at home, or we are a student, or we are a kid, or we are anybody, we are just talking whole day. Okay. Many telecommunication companies in this country and also other countries also, they record it that this number, I mean, for every number, they are talking to whom, they are talking what content, and they are talking about, they are talking how long. So they store some information, and they claim, let's assume they do, so they store this information anonymously. So there's a store, data store near you in Nagpur. If you go there, or if you go to Sprint in different countries, Sprint is also a telecommunication company like Jio and Airtel in India. They have this stored data that we have, let's say, two, it's not two, 20 million customer, and they are talking 8 hours per day over phone. Excellent. And they are talking about so many things, maybe food, maybe some traveling, maybe something else, maybe clothes, maybe shopping, something else. Can we analyze it? So let's say you go to the company as a analyst, as a statistician, as a researcher, and they ask you, can you analyze it? Which already many companies are doing. Maybe like Netflix is one company. So many people watch Netflix. They are analyzing that we have so many customers. They are watching movies, TV shows, these web series, etc. What people are watching, can we analyze it? So you have to see how many people data you can analyze and what kind of parameter you have to choose. They have more than 200, at least 200, depend on company to company, at least 200 parameter for each user. And the users are 20 million. So there is a matrix of 20 million cross 200, such a big matrix. And you have to bring some information. Which information? They don't know, because they are the business people and you are the technical expert. You have to tell which one. If you take a sample, you can say, okay, most of the people are liking this. But is that sample correct? That is a big question. Same as exit poll. Why exit poll fails? Because of the sample chosen wrongly. So kind of data we have and the kind of size of data, the very big data we have, the sample need to be very carefully chosen. Okay, if anybody has a question, please let me know. Otherwise, we can close it. So Lakshmi, we can close it.
We can. I'll just ask once again the participants. If any participant has any query, they can shoot their question directly to show by unmuting yourself, or you can even drop your queries in the chat box.
If somebody is speaking something.
Any participants, if they have any queries, they can directly shoot their queries directly to sir by unmuting themselves, or they can directly post the query in the chat box. So I think nobody has a query.
Okay, then we can close it.
Yeah, we can. Thank you so much, sir. It's a pleasure having you here today. For this session, it was very informative, and you gave us a broad spectrum about how to choose the samples for the research process. Or even you gave with the marketing perspective also that how to go about. So it was definitely a very informative session, and I hope each and every participant here have really gained a good amount of knowledge from your session. Thank you so much.
You're welcome.
Also, I would request you if you can share this presentation with us so we can share with the participants.
Sure, I will email to you.
Thank you so much, sir.
Okay.
Requesting all the participants, Namrata ma'am is again posting the feedback and quiz link. Please make sure that you fill in the feedback and the quiz link. And we'll be only posting it at the end of the session. After every session, we'll be posting both this link. I would request everyone to keep a check in the chat box whenever we are posting. We won't be posting it on personal chats or in the group. I can see few. Ma'am, am I audible now, Satya ma'am?
Ma'am, you're audible, but your voice is quite breaking.
It's breaking till now.
Not yet.
Is it okay, ma'am?
Yes.
Thank you so much. I'm requesting each and every participant again. Namrata ma'am has posted the links for quiz and feedback. Kindly fill both the forms. We'll be posting it again every time after the end of the session. Please don't ask us to send it across in the group or in the personal chat or over email. I can see few participants asking us to post it again and again. That is not possible for us because we are instructed to post it twice. So we post it twice. So please stay connected in the overall session so that you get the links on time.